Force and pressure. Subtopic: forces and pressure. Forces and moments. A spanner is a device which is used to tighten and loose nut. They help to produce a larger turning effect. The turning effect of a force is called as a moment. The longer the spanner, the greater is the turning effect of force. Moment of a force about a fixed point is force into perpendicular distance from the point. Moment may be described as clockwise or anti-clockwise, and the moment of force is also called as torque. To increase the force applied to undoing a wheel nut, extend the length of the spanner. You can do this by inserting a length of pipe over the end. We say that this beam is under the state of balance. In order to be balanced, the clockwise forces must be equal to anti-clockwise forces. We say that the beam is in the state of equilibrium. The principle of moments states that if an object is in equilibrium, the sum of the clockwise moment about any point is equal to the sum of anti-clockwise moment about that point. Center of mass. If you look at this particular object, it has got its tiny particle exerting gravitational force on either sides of the point G. When the gravitational force on either side of G are equal, the rule is said to be balanced. The forces now act together at the resultant force G, which is nothing but the weight. So G is the point of center of mass, which is also called as center of gravity. How to find the center of mass of an irregularly shaped object? Take an irregular shaped object and a thread and a mass. Fix this irregular shaped object with the help of a pin and allow it to rest. Now, the line where the thread lies, draw a line over there. Then take another end of the object and fix it with a pin. Again, align the line over there. Where the two lines intersect, that point is the center of mass of the object. Center of mass and stability. If the force is applied, which box will be more stable? First, second, third, fourth, or fifth? We say that the wider the base of the object, the more stable it is. Center of mass is exactly at the center of the object. Weight is acting at that point, and a reaction force, which is upward force, is given from the ground. The box is here in equilibrium. Forces are balanced, hence there is no turning effect. When you slightly tilt the object, if a small force is applied, the upward force and the downward force will act on the object and will return the object to its original position. If you apply more force, the center of mass crosses the line of contact. Therefore, the object is not in equilibrium and here it is falling. Therefore, we say that the object is not stable. So, if an object has a wider base, then it is difficult to tip the object. Therefore, wider the base, more is the stability. If a box has a wider base and a lower center of gravity, then it will be harder to tip over. That is the reason the sumo wrestlers come into this particular position before their fight. Hooke's law. Hooke's law is a law which deals with the relationship between the load applied and the extension in the spring. Hooke's law says that the amount of spring stretches is directly proportional to the force applied to it. That means if you double the load, the extension will be double. This can be plotted on a graph where force is on y-axis and extension is on x-axis. The gradient of force upon extension gives the spring constant, which is K. Therefore, the formula becomes force is equal to K into X, where F is the load, K is the spring constant, and X is the extension. Up to a certain point X, the extension is directly proportional to the load. This point X is called as limit of proportionality. For any spring, dividing the force by extension gives the value of the spring constant, provided that the spring is not stretched beyond its elastic limit or limit of proportionality. Beyond point X, the spring continues to behave elastically and returns to its original length when the force is removed. At the elastic limit, the spring behaves in a plastic way and does not return to its original length. It becomes permanently stretched. What would be more painful? Being trodden on by a 55 kg woman wearing a stiletto's heel, or being trodden by a 3-ton elephant? The woman's foot in the stiletto's heel, the whole of the woman's weight is concentrated on a small area, whereas the elephant's weight is much more spread out. It exerts less pressure. Therefore, pressure is equal to force upon area. Force is measured in Newton, area is measured in meter. Therefore, the unit of pressure is Newton per meter square. Another name for Newton per meter square is Pascal. Examples of pressure: increasing the pressure by reducing the area. The area under the edge of a blade of a knife is very small. Beneath it, the pressure is very high. So, blade can be pushed easily through materials such as fruits. The studs on a football boot have a small area of contact with the ground. This means that the pressure beneath the stud is sufficient for them to sink into the ground and provide additional grip. The skis have a large area to reduce the pressure on the snow so they do not sink in too deep. The wall foundation have a large area. This reduces the pressure beneath so that it does not sink deeper into the ground. Air pressure. Air pressure in the atmosphere acts in all directions. Air pressure gets less as you rise up through the atmosphere. The atmosphere is denser at lower level. At sea level, the atmospheric pressure is about 100 kilopascal. Crushed can experiment. So, if there is a can which is open lid, the internal pressure is equal to external pressure. Therefore, it remains stable. As soon as you remove the air inside the can with the help of a vacuum, the external pressure is greater than the internal pressure. Therefore, the can gets crushed. How to measure air pressure? To measure air pressure, we have a device which is called as barometer. The barometer consists of mercury, a sealed tube, and some container. The sealed tube contains a vacuum. Air pressure will push the mercury up to the tube at a sea level of a column of 760 millimeter of mercury. As atmospheric pressure changes, so does the height of the mercury in the tube changes. Pressure in liquids. The weight of the liquid causes pressure in the container. It also causes pressure on any object in the liquid. Pressure acts in all directions. The liquid pushes on all surfaces it is in contact with. For a submarine, this means that pressure is being exerted equally on all the parts of the hull. As you can see in the diagram, as you go deeper and deeper into the sea, the pressure increases. So in liquids, pressure increases with depth. Pressure increasing with depth, the deeper the liquid, the greater is the weight above, and so it will be at a higher pressure. This is why dams are built with taper towards a thicker base. So pressure depends upon the density of the liquid. The more the dense the liquid is, the higher is the pressure at given depth. Pressure in liquids is purely dependent on the height and the density. It does not depend on the shape of the container. Therefore, for any shape of the container, the pressure remains the same for a particular height. Pressure in liquids calculation. Pressure at any given point is calculated by density into gravity into height, also rho gh. Manometer. A manometer is a device which measures difference in pressure. The height h compares the pressure being measured with the comparison to atmospheric pressure. In this example, the pressure being measured is less than the atmospheric pressure. That is the reason atmosphere pushes the mercury down.